triangle is the basic geometric shape, and the branch of mathematics that studies the relationship between the sides and angles of triangle is trigonometry. One of the geometric concepts that involves triangle is the triangle congruence. How do we know that the two triangles are congruent without actually measuring its parts? Just stick around, for in this video, we will be discussing triangle congruence. This video includes key terms and concepts that will help you understand this lesson easily. If you are new to this channel, kindly hit that subscribe button and the notification bell, and I promise that I will journey with you in learning math lessons and concepts in an easy way. Triangle congruence. After watching this video, you will be able to illustrate triangle congruence, illustrates the side angle side, angle, and angle side congruence postulates. Prior to the discussion of the lesson, we will discuss first key terms and concepts that will help understand this lesson. First, the concept on congruence. Now, let's illustrate this one in these two sets of examples. First column are examples that involves congruence, and second, the counter examples. So these two geometric figures, the 5 peso coin, this is the face and the head. These two geometric figures are congruent. In contrary, this 5 peso coin and this 1 peso coin are not congruent. This 20 peso bill is congruent to 100 peso bill. But in contrary, these two 5 peso coins are not congruent. Now, how do we know that two geometric figures are congruent? So, based on this set of example, two geometric figures are congruent if they have the same size and shape. Now, this is the symbol of congruence. So, in the previous lesson, we discussed about ray. Ray is part of a line that has an endpoint extending in one direction infinitely. So suppose this is point A and this is point B, and we have another ray that shares common endpoint. This is point C. These two rays form another geometric figures and we call it as angle. So angle basically formed by two rays sharing common endpoint. And the common endpoint, we call it as a vertex. So take note, vertex is a point. Now, the sides of an angle are ray AB and ray AC. How do we name an angle? So, we can name an angle in different ways. If we will be using the three identified points, the common endpoint, which is the vertex, must be put in the middle. So, say for example, you can name this angle as angle BAC, or it can be named as angle CAB. So, this can be named as the vertex. Or if there is a symbol in between that represents the angle, so that could be the name also of an angle. So this is angle theta. Now let's suppose we have the same angle and there's another ray here. We have an identified point B here. So and this ray divides the angle into two equal parts. So how do we call this ray? So this ray is called an angle bisector. So angle bisector is a ray, or it could be a segment that divides the angle into two congruent angles. So in this case, angle BAD is congruent to angle DAC. Suppose we have this triangle. Let's call this one as point A, point B, and point C. So points A, B, and C are the vertices of a triangle. The plural form for vertex is vertices. So if we have a segment here, in the previous lesson, a segment perpendicular to the opposite side is a segment that forms a right angle. We call this as an altitude or the height of the triangle. So altitude is the segment connected from the vertex perpendicular to the opposite side. Suppose we have a point here, and this is the midpoint. This midpoint divides this segment into two equal parts. So if we have another segment that connects the vertex and the midpoint of the opposite side, this segment is called the median. Now, suppose in this triangle, we have this segment and we have another segment. So, these two segments form an angle in a triangle. So, this angle is known as an included angle. So, included angle is an angle formed by two sides of a triangle. So, in this case, angle B is the included side of segment BA and segment BC. How can we name a triangle? Now, in naming a triangle, we will name a triangle using the three vertices. So, first, the name of this triangle could be triangle ABC. Secondly, it could be named as triangle ACB. Thirdly, it could be named as triangle BCA, triangle BAC, triangle CAB, and lastly, triangle CBA. So, these are the possible names of the same triangle. Now, suppose we have two vertices of a triangle. This side is called an included side. So, included side of a triangle is a side whose endpoints are the vertices of a triangle. So, in this case, BC is the included side of angle B and angle C. Now, corresponding parts of two triangles. Suppose we have this triangle ABC. We also have another triangle here, which is a DEF. Now, the corresponding angles are the following. So, angle A corresponds to angle F. So, the symbol for corresponding is double-headed arrow. So, angle B corresponds to angle E. And lastly, angle C corresponds to angle D. When it comes to side AB corresponds to side EF. And side AC corresponds to side DF. And lastly, side BC corresponds to side DE. As reflected on the illustration, angle A is congruent to angle F, angle B is congruent to angle E, and angle C is congruent to angle D. Same is true with the corresponding sides. Segment AB is congruent to segment EF, AC is congruent to DF, then BC is congruent to DE. Now, if the corresponding parts, the sides and the angles of the two triangles are congruent, then we can say that the two triangles are congruent. So, triangle ABC is congruent to triangle FED. Now, in stating the statement of congruency, the corresponding angles must be the corresponding angle. So, since A corresponds to angle F, so the first point here must be F, followed by B and C respectively. If we establish that the corresponding parts of the triangles are congruent, we call it as CPCTC. Or CPCTC stands for the corresponding parts of congruent triangles are congruent. Or it can be stated in a conditional form that says, if the corresponding parts of two triangles are congruent, then the two triangles are congruent. These are the properties of congruence that will help us also prove that two triangles are congruent applying the triangle congruence postulates. So first is the reflexive property. We all know that reflexive property is a number or a quantity is equal to itself. So let's say angle A is congruent to angle A, or segment AB is congruent to segment AB. We also have the second property, we call it a symmetric property. In symmetric property, it was illustrated as if angle A is congruent to angle B, then we can say that angle A is congruent to angle B. So we just reversed. Or if segment AB is congruent to segment DE, then DE is congruent to segment AB. And lastly, the transitive property of congruence. So this involves three quantities. So if angle A is congruent to angle B, then angle B is congruent to angle C, then angle A is congruent to angle C. If segment AB is congruent to DE and DE is congruent to FG, then AB is congruent to FG. After learning these key terms and concepts in geometry, I believe we are now ready to discuss or illustrate triangle congruence postulates. So let's illustrate this concept using these two triangles. So this is triangle ABC and triangle EDF. So suppose AB is congruent to segment ED. So we will write this in the congruent statement, which is AB is congruent to EF. And also we have AC congruent to EF. And thirdly, we have segment BC congruent to segment DF. So this illustrates the side postulate. How do we know that two triangles are congruent? By side postulates. It states that if the corresponding sides of two triangles are congruent, then we can conclude that the two triangles are congruent. So in this case, triangle ABC is congruent to triangle EDF. Now let us illustrate that the two triangles are congruent using the postulates. Suppose we have this triangle ABC and we have another point here, which is point D. So the first given statement that side AB is congruent to side AC. Another statement, D is the midpoint of BC. So D is the midpoint of BC, so we can draw a median. So from the vertex to the midpoint of the opposite side. Now we are asked to prove that this two triangle ABD is congruent to triangle ACD without actually measuring the parts of the triangle by just using the postulate. In making a geometric proof, we can do it in two ways. It's either in a two-column form or it could be a paragraph form. But in this case, we will make use of a two-column proof because a two-column proof consists of a list of statements and reasons that we know that they are true. The statements are listed in the column at the left, then the corresponding reasons will be written at the right. The technique in making a two-column proof, we will make use of the given statement. And out of that given statement, try to figure out what succeeding statements that we can state as true based on the different concepts of geometry that we know. First statement, AB is congruent to AC. So the reason why we say that this statement is true is because it is the given statement. We can also say that D is the midpoint of BD. So what is the reason why we said so that this statement is true? Because again, this is given. Since we established that these two sides are congruent, so we put identical markings on the triangle. We all knew that the midpoint divides the segment into two equal parts. So since it was established that D is the midpoint of the segment BD, therefore we can have this statement number 3 as BD congruent to DC. What's the reason? Because of the definition of midpoint. Midpoint divides the segment into two equal parts. So we can put identical markings here, showing that these two segments are congruent. So take note, in side postulates, we need to establish three corresponding sides of the two triangles are congruent. What we need to establish is the third side. And we all knew that this median here, this segment, is common to these two triangles. Now we can have the statement number 4 that says that AD is congruent to AD. So a segment is congruent to itself. What allows us to state this statement? Because of the reflexive property. So since this side is common and all the three corresponding parts are congruent, then we can now conclude that the triangle ABD, you just bring this one here as our conclusion, are congruent because of the side postulate. Now let's have another postulate and let's illustrate this one using these two triangles. So again, this segment AB is congruent to segment ED, and segment AC is congruent to segment EF, and the included angle of these two segments which are also congruent. Angle A is congruent to angle E, and this statement of congruency illustrates that the two triangles are congruent by this side angle side postulate. So side angle side postulate states that if the two sides and the included angle of one triangle are congruent to the two sides and included angle of another triangle, then the two triangles are congruent. Now, let us prove that these two triangles are congruent using that postulates, the side angle side. So, the given statement, point E is the midpoint of segment AD and BC, and we are asked to prove the triangle AEB is congruent to triangle CED. So, first statement, of course, the given statement. So, we just copy this given statement, and the reason is given. So, out from this given two statement that E is the midpoint of these two segments, we can actually generate two statements. First, we can say that the segment AE is congruent to segment ED. Why? Because the reason is the definition of the midpoint. Or you can state the definition of the midpoint, that is, midpoint divides the segment into two equal parts. We can also say that BE is congruent to EC. So again, the reason is the definition of the midpoint. So take note, we have to write in the two-column proof first our given statement, because without this statement, we cannot state these two succeeding statements. So that is why we have to plan and we have to organize the order of statements so that we will be able to have the continuity and the order of correct statements. We can also say that since these two angles are vertical angles, then vertical angles are congruent. So we can say that angle AEB is congruent to angle CED. The reason is vertical angles are congruent. By virtue of the postulate side, angle, side, we can now conclude that these two triangles are congruent. Now, let's have another triangle congruence postulates. Again, by illustrating these two triangles. Suppose angle C, which is congruent to angle F. Angle A is also congruent to angle E. Now, its included side is side AC and side EF respectively, and they are also congruent. Now, we can state that these two triangles are congruent by angle side angle postulate. Angle side angle postulate states that if the two angles and the included side of one triangle are congruent to the two angles and included side of another triangle, then the two triangles are congruent. Now, let us prove that the two triangles are congruent using the angle side angle postulate. So, we have this triangle ABC and the given statement that AD is a perpendicular bisector of BC. Suppose this is a midpoint. So, this segment from the vertex to the midpoint of the opposite side. So, perpendicular, that means that this segment forms a right angle to the opposite side. At the same time, this segment is the bisector of angle BAC. That would mean this segment divides this angle A into two equal parts. So, first statement, the given statement. So, you will write it, the reason as given here. Then secondly, so since this is the perpendicular bisectors, so from the word bisector, we can have the next statement that angle BAD is congruent to angle CAD. The reason is the definition of an angle bisector. Third statement, so since this is perpendicular, so this form a right angle. The straight angle measures 180 degrees. So if this is 90, the other side is also 90. So we can state also that angle BDA is congruent to angle CDA by virtue of the definition of perpendicular bisector. We need to establish that one side of these two triangles are congruent. This side AD is common side of these two triangles. By reflexive property, we will establish these sides is equal to itself. So since these two angles and the included sides of these two triangles are congruent, now by virtue of the angle side angle postulate, this statement is true. Let us now illustrate another triangle congruence postulate using these two triangles. Suppose we have this angle which is congruent to angle F also. And we have another angle, angle A, which is also congruent to angle E. So this side BC is the non-included side because the included side of these two angle A and C is side AC. If we establish that these two angles and the non-included sides of one triangle is congruent to corresponding parts of another triangle, then these two triangles are congruent by angle-angle side postulate. So angle-angle side postulate states that if the two angles and the non-included side of one triangle congruent to the corresponding parts of another triangle, then the two triangles are congruent. Suppose we have triangle ABC. Now the given statement, AD is the bisector of BC and angle B is congruent to angle C. This is the midpoint because this is bisector, so it divides also this segment into two equal parts. So we can draw a segment that joins the midpoint and the vertex of this triangle. So first statement, the given statement, since this segment AD is the bisector, out from this statement, we can have another statement that angle BAD is congruent to angle CAD. The reason, the definition of angle bisector. Then thirdly, we have another statement that says that angle B is congruent to angle C. So reason given. Now establish that these common side are also congruent. So that is AD congruent to AD, and that is by virtue of reflexive property. So the two angles are congruent and the non-included side is also congruent of the two triangles. Then we can say that this triangle ABD is congruent to triangle ACD by angle-angle side postulate. Now, after learning the lesson for today, it's now a time for you to measure your understanding. Write your answer of each item in the comment section below. So for each pair of triangles, state the postulates that can be used to conclude that the two triangles are congruent. So first, second, third, fourth, fifth, and last one. Just write your answer in the comment section below.
Thank you for finishing this video. If you learned something new today, kindly smash that like button. And in the comment section, kindly send me your thoughts about this video. Please don't forget to subscribe and share this video so that I will be able to continue to journey with you in learning math lessons in an easy way. See you in our next video. Thank you for watching.